Hey, Algebra 1 class. This is a fairly long lesson, so pay attention. It's somewhat complicated too. So let's give this a whirl. We are doing lesson 66. So let's see if I can write that up here. We'll do that in yellow today. This is lesson. It's such a bright, cheery day out here. No. Lesson 66. We're doing simplification of radical expressions, square roots of large numbers. So remember, this is just to recall from last time, we did something like the square root of 50, and we had to simplify that. That's like having a fraction that's not reduced. This is not in its simplest form, so our job last time was to get it in the simplest form. And what I told you to do was to take all your perfect squares, so you have 4, 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36. For a while, you can write these on your paper if you need to. 64, 81, and sometimes it goes over 100, but mostly it stops by the time you get to 10 times 10. So we talked about there's different ways to do this. The way that I like to do it, I think it's the fastest way, though not the easiest way, is to look over here at your list and say what's the biggest perfect square that will divide into 50. And if I look, 40 goes into 50, but it's not the biggest perfect square. So, actually it doesn't go into 50. So then we'll go down to 25. 25 will go into 50. So we break it into the biggest perfect square, and then what's left. So 25 times 2 gives us 50. So we divide that up, and then we know that the first one should be our perfect square. So square root of 5, or what times what gives us 20, square root of 25, or what times what gives us 25 is 5. So we get an answer 5 square root of 2. There's the other way you can do this. I'll just show you that real quick. I'm going to take my time with this video, so it might be kind of long. So we could divide this into its prime numbers. We could take 50, and we could say, we can divide that into 25 times 2, and then we could divide that into 5 times 5. So these are our prime numbers. So we could have 5, we take the pair, and we would say, okay, if we take one of those out, it's going to be 5 square root of 2. Actually, I'm not sure we did this in class. So that's just another way you can do it in prime. When you hit a double, you take out one of the numbers. The square root of 5 times the square root would be the square root of 5 times the square root of 5. If I take all the prime factorization, square root of 2. And the square root of something times itself is just the number, 5 square root of 2. That's the other way to do it, is the prime factorization. I think this way is just faster, and it's more, when you get into higher math, you don't want to be doing trees all the time. So let's look at our first example for lesson 61. This one is simplification of radical expressions, and then we're going to do square roots of even bigger numbers than these. So the first one is the square root of 18 plus the square root of 8. So what we're doing is we're going to simplify. We have two radicals to simplify. We're going to simplify those, and then we can see if we can add them together like in lesson 65. So I'm going to look at the square root of 18. I'm going to go up and I'm going to look at my square roots. I'm going to say, what's the biggest square root that goes into 18? 4 doesn't go into 18. 9 goes into 18, and obviously 16 won't go into 18. So 9 is the biggest square root. So I'm going to split this into the square root of 9, and then what's left would be 2. Same with the 8. I look at 8, what's the biggest square root? 4 is the biggest one. So it's going to be the square root of 4 times the square root of 2. Now we can simplify that. That would be 3. Square root of 9 is 3, square root of 2, plus 2 square root of 2. And then, since they're both the square root of 2, they're like terms, so we can add them together and we get 5 square root of 2. So we did a simplification and then we did an addition problem. Why don't you try this one, see if you can get it. Pause the video and then come back and see how it's done. So this one, number 2, is 8 square root of 27. It's a little harder. And plus minus 3 square root of 25. 3 square root of 75. Now in this one, you're going to notice there's numbers in front. Whatever you get taken out will have to be taken times that number. Why don't you give it a try? Try simplifying. If nothing else, try simplifying the square root of 27 and the square root of 75. See if you can get those simplified, and then come back to the video and I'll show you what to do next. So pause the video now and come back. Alright, hopefully you paused the video and just didn't wait for it to start over again. So what I said for you to do was just at least figure out the square root of 27. So I'm going to look up here. The biggest number that goes into 27 is 9. So I'm going to get the square root of 9. What's left would be 3. Because the square root of 9, because 9 times 3 is 27. And then over here, the square root of 75, the biggest one would be 25. So it's the square root of 25, square root of 3. And then we continue to simplify. These are all multiplied together. So it's 8 times 3, square root of 9 is 3, square root of 3, minus 3 times 5, square root of 3. And that's going to be 24 square root of 3, minus 15 square root of 3. And that gives us a nice, neat answer of 9 square root of 3. Not too bad. I don't think these are too hard. Let's look at one more of these. Actually, I want you to try to do this one on your own once again, and then come back to see if you can get it. This is the same as example 2. They're just adding one more term. So we have the square root of 27 minus 3 square root of 18 minus 6 square root of 45. Let me make sure I have that right. Oh, my computer just unplugged. Oh, it's still back on. Huh, still recording. Alright, my computer went off, but it appears as if it's still recording. So I'm not sure what we do with that. Alright, so you were supposed to turn off your screen, pause the video, and do this problem. So if you didn't pause it now. My power went out on my computer, and I don't know if it just left a gap or what happened. So, so pause it and come back. Alright, so let's see if you got the same answer that I'm going to get. Square root of 27. We have the biggest perfect square that divides into 27. Look over on our list is 9. It's the biggest one that divides into 27. You get really good at this after a while. So square root of 9 times the square root of 3. Then over here we have 3. The biggest square root again is 9. And we're left with 2. And the biggest square root again is 9, I do believe. So it'd be the square root of 9 times the square root of 5. So we're going to get 3 square root of 3 minus 3 times 3 square root of 2, because the square root of 9 is 3, minus 6 square root of 6 times 3 square root of 5. All these square roots are different, so we're not going to be able to add those all together at the end. So we're going to final answer 3 square root of 3 minus 9 square root of 2 minus 18 square root of 5, and that is our final answer. Alright, I'm going to erase all of this, and we're going to do the second half of the lesson. So I'm not real good at erasing things, but I'm going to try here. Ooh. Let's see. Color. I think I'll just wipe all this out. I don't know how to erase. Well, let me use my eraser, I guess. Actually, I'll try putting a rectangle on top of it. And actually, I think I'll just do a new screen. And there we go. Alright, so let's move on to the second part of the lesson. This is still square roots. So we're going to do larger square roots. This is example 4. And we're going to have simplify the square root of, check this out, 50,000. Now the key with this is if you have an even number of zeros, the square root of it is going to be half the number of zeros. For example, we can split this into the square root of 5, and then what's left is 10,000, or is 10,000, right? If it has an even number of zeros, when we take the square root of it, it's just going to be half of the number of zeros. So that's going to be our final answer. This is a perfect square. If it has an even number of zeros, and it starts with a 1, of course, it's going to be a perfect square. So when we split these up, when we split a number up, we're going to put something and then 1 with an even number of zeros. And if it has an even number of zeros, the square root of it's going to be half the number of zeros. So that's that. Let's try another one, see if you can get the idea of it, the hang of it. This one is similar. It's 500,000. You'll notice this time we don't have an even number of zeros. We have 5 zeros. So what we want to do is split it into 50 and then 1 with even number of zeros. So now we have even number of zeros. If you were to multiply these two together, you just count up the zeros. 1, 2, 3, 4, 5. That's why we have 5 here. So we split it into an even number of zeros and what's left. So we left 1 0 with the 50, and then we put the other 4 zeros over here. Now we're going to simplify. We know that this is going to be half the number of zeros, so it's going to be 100 square root of 50. Now you could be tempted to stop right there, but this isn't simplified yet. Remember our square root chart that we had over here that got erased over the last lesson? So let's just do a few of these. We can see that the biggest perfect square that will go into 50 is 25. So we're going to have 100 square root of 25 square root of 2. 100 times 5 square root of 2 is going to give us 500 square root of 2. And that's your final answer. Let's try another one. Almost done. It's a rather long lesson. Here we go. This is a big one. This one is 40 million. 40 million. Now the whole goal when you get to these big numbers is you want to have an even number of zeros in one of the radicals with the 1 on it. So we need 1, 2, 3, 4, 5, 6. So we're going to have, we need to take off one of the zeros. So I'm going to leave one of the zeros with the 40, and then we're going to have 6 zeros, which would be 1 million. And the other one. See how 40 times 1 million is 40 million? I just put the even number of zeros in this one, and then I had to take this extra 0 and leave it in this radical. So we know the square root of an even number, you just take half the number of zeros, so there's 6 zeros. So we're going to put the square root would be 3 zeros. So it would be 1,000 square root of 40. But we're not done yet because a 4 goes into this one. So we're going to have 1,000 square root of 4 square root of 10. 1,000 times 2 square root of 10. So we're going to get 2,000 square root of 10. Why don't you try this last one? I think this is the last example, and we'll be done. So example 7. You try this one. Find the square root of 700 million. So put the video on pause, try this one, and then come back to see if you can get it. Alright, hopefully you tried it. So let's count our zeros. We have 3, 6, 9. That's not an even number. So we need to leave one of the zeros with a 7, and we're going to have 6 zeros once again. We're going to have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. Actually, it is an even number of zeros, so we won't do that. This one is actually easier. So we're going to have the square root of 7, and this is an even number of zeros, so we're going to have 100 million. The whole idea is to leave one of these with an even number of zeros. So we have square root of 7 times, I wrote this backwards, so it's going to be half. Since there's 8 zeros, it's just going to be, we're going to have 4 zeros. So it's going to be 10,000 square root of 7. 8 zeros, so you leave all 8 under here, so none needed to go with the 7. So in the square root of even numbers of zeros is half the number of zeros. So that's it for lesson 66, and we'll see you in class tomorrow.